Hi, this is Tim, and in the last video I asked if there was anything I needed to clarify in our RS Logix 500-bit instruction video series. And Sam said that I needed to clarify that a normally open and normally closed PLC instruction is not the same as a normally open and normally closed electrical contact. I was really hoping to avoid this specific video because I think it brings on a lot of controversy, but here we go. I'm going to try to walk through this as delicately as possible. There are three main questions I see on tests that lead students down a path to not understanding PLCs. One is the last rung wins, which we debunked in another video. I'll put a link to it in the description. The other two are that this instruction, whatever you may call it, should be considered a normally open contact, and this instruction should be considered a normally closed contact. What I want to do is walk through a very common rung using these normally open and normally closed terms just to show how confusing it makes it and why it makes so many potential programmers just throw up their hands and quit. And for this video I'm going to use an Automation Direct PLC which exclusively uses these normally open and normally closed terms. And I'm not doing it to pick on Automation Direct. I use Automation Direct a lot. In fact, I think Automation Direct rocks. I'm going to do it to show how you can think about these instructions no matter what they're called in your particular PLC in a way that will always work. So here we are in Automation Direct's Click programming software, and I love their layout of this software because right here on the right side is everything you need to write your program. And right at the top we can see Contact NO and Contact NC. And if you're not sure what they stand for, just double click them and hit the help button because Automation Direct has a great help section. And it says here, the normally open contact mimics the behavior of a physical contact and changes state in response to the status of the bit memory address. The normally closed contact mimics the behavior of physical contact that changes in response to the status of a bit memory address. The normally closed contact is on when the related bit is off. Now I know what they're trying to say here, but if you're just learning about PLCs and possibly the week before you just learned about normally open and normally closed electrical contacts, then this is clear as mud. Now my by the book viewers are saying, well, an electrical course should be a prerequisite to a PLC programming course, but it doesn't happen that way. In many cases, a PLC programming course is the first practical electrical experience that someone gets. So we're going to lay out a very common forward-reverse interlock. We're going to add a normally open contact to X1, and we're going to add a normally closed contact for X2, and we're going to turn on Y1. And we'll go ahead and add descriptions just to make this really clear. Hey, while I'm at this, does anybody know an easier way to be right here and add a description in Automation Direct? I'm sure there is, I just never had found it. But so X1 we're going to call the forward push button. Then X2 we're going to call the reverse push button, and then Y1 we're going to call the forward output. We're going to go up here to view and we're going to check the address comments. And so this is a very common interlock. I'm not even going to worry about the reverse side of this. I'm just going to concentrate on this forward output. We have a normally open and a normally closed PLC instruction, but both of these are connected to a normally open electrical contact. You would not believe the people, including instructors, that I've had to convince that you don't have to use a normally open PLC instruction with a normally open electrical contact or a normally closed electrical contact with a normally closed PLC instruction. Now some of you more experienced viewers are going to think that's crazy when you just learned the electrical and PLC definitions of these symbols that seem to have nearly the same definition. It's not that hard. Plus, you already have to group syncing, sourcing, NPN, PNP, positive, negative. It seems like everything has to match up. Now running through this terminology, if a normally open PLC instruction is on, which is connected to a normally open forward electrical contact, which will need to be on for the PLC instruction to be on, and the normally closed PLC instruction is on, which is connected to the normally closed reverse contact, which needs to be off for the PLC instruction to be on, then the output will turn on. I can't believe I actually got all that out in one sentence, and I'm not even sure I got it right. But my point is, having these same naming conventions of normally open and normally closed in electrical and PLC makes it hard not to associate them as being the same thing. Yet they have two very different definitions. What is normal about either of these instructions? Whether you're an Automation Direct PLC, an Allen Bradley, an Omron, a Siemens, or any other brand of PLC, if you will always say that this symbol goes and looks for a 1, then it will always work. And this symbol goes and looks for a 0, then you'll always be right. This symbol goes and looks for a 1. Where? In X1's memory address. This symbol goes and looks for a 0. Where? In X2's memory address. I use these PLCs all the time, and I never look in that right-hand pane and say, yeah, normally open, normally closed. In fact, I probably think F2, F3 more than anything because that's their keyboard shortcuts. But I can tell you, if you think of them as dog, cat, left, right, up, down, light, dark, anything but normally open and normally closed, then you will quickly accelerate a grasping PLC programming. I hope this video has been helpful, and I would love to have some constructive discussion on how we can better clarify these terms. But I can tell you most of the arguments I had against my last rung wins video were that the last rung wins most of the time, so it should be considered a true statement. If it isn't repeatable every time, then something's wrong with the definition. I understand that PLC programming is rooted in relay ladder logic, but it doesn't make their definitions remotely associable. Now, some of you are probably pulling up your old test, scratching your head, or maybe looking to show me that I'm wrong. Well, here it is, right out of a world-class PLC certification. The symbol shown here in the ladder diagram can be thought of as a contact that is usually open. This contact is normally open. Most of the time this contact is open. Well, usually it's open. What is connected to the PLC terminal will determine what is normal. And this instruction just goes and looks for a 1. Till next time.